Let's look at the 2021 JAMB Chemistry examination question 1 to 10. Question 1 says, copper metal dissolved in concentrated trioxynitrate 5 acid with her resultant evolution of A. Carbon 4 oxide, B. Sulfur 4 oxide, C. Nitrogen 4 oxide, D. Carbon monoxide or carbon 2 oxide. So what is the answer to this question? Now for this question, you have copper metal being dissolved in concentrated trioxynitrate 5 acid. Let's write out the full equation of this reaction. So for question 1, the full equation of the reaction is simply copper plus hydrogen trioxynitrate 5. This to give you, this would be copper trioxynitrate. This, here's my first product. This plus, you have NO2, that's nitrogen dioxide, plus you have water. So water will be given off. If you balance this up, this would be 2. You have 2 moles of NO2, and of course you have 4 moles of this. So basically, this is the balanced reaction of, this is the balanced equation of the reaction. You have this. So looking at this, you can see that what will be given off is NO2. That is nitrogen 4 oxide. All right. So the correct answer here for number 1 is C, NO2. That's your correct answer. Question 2. Question 2 says, what number of moles of copper 2 ion will be deposited by 360 coulombs of electricity? Take Faraday's constant as 96,500 coulomb per mole. You have option A, B, C, and D. So how do we solve this question? So for question 2 here, the first thing we want to notice that they gave us the total charge, or we're given total charge, that's Q, as equal to 360 coulomb. That's the charge given there. Also, they gave us Faraday's constant, F. So Faraday's constant, let's call this Faraday's constant. Faraday's constant, that's F. The value there is given as 96,500. So 96,500 coulomb per mole. So we have this. All right, so we have this. Okay. Now, the first thing we want to do here is that we want to get the number of moles of electrons delivered. That's the first we do. So first things first, let's find the number of moles of electrons delivered. And how do we find this? Delivered. And how do we find this? Let's call this number of moles of electron E. This will be equal to the ratio of charge Q all over Faraday's constant. The charge given in this question, total charge, is 360. So it becomes 360. That's the charge all over Faraday's constant, 96500. So if you punch this, I'll get my calculator and I'll punch 360 divided by 96500 equal to, now my calculator gives me my answer here as 0.003732. So you have this. So this is the number of these moles of electrons. You have this. All right, so far so good. I've gotten the number of moles of electron delivered. Now after this, let's look at the reaction of the deposition. What is the reaction of deposition? So reaction of deposition. So all you have is this. You have the copper 2 ion, Cu2 plus, this combining with 2 moles of an electron, and that will give you copper. That's copper metal. You have this. right? So you want to note that each mole of copper 2 ion, each mole of Cu2 plus copper 2 ion requires 2 moles 2 moles of electron, as you can see here. So 1 mole of copper 2 ion requires 2 moles of electron, as you can see in the equation of the reaction. So from here we have that. So the number of moles, so the moles of copper deposited, to get this value, since each mole of copper 2 ion requires 2 moles of electron, the number of moles of copper deposited would be, let's call this N of Cu, right? Number of moles of copper deposited. This would be equal to the number of moles of electron delivered. That's this, you divide it by 2, because you require 2 moles of electron for each of them. So when we do this, what do we get? If I impute values, this is equal to, this value is, we got this earlier. Let's see this one here, 0.003732. So that's 0.003732 divided by 2. So divide this by 2. What do you have there? The number of moles of copper deposited would be equal to 0.001866. So you have this moles. So this mole. All right. If I have this value here, let's express this value here in index form. This is equal to 1 point. Let's put the point here. So this becomes 1, 2, 3. That's minus 3. But what I have here is 1.86 is plus 1 here. So 6 plus 1 gives you 7. 1.87 times 10 to power minus 3. I went back 3 times. So 3 moles of copper 2 ion. So 1.87 times 10 to the power minus 3 is my answer. Let's see. 1.7 times 10 to the power minus 1.87 times 10 to the power minus 3. That should be this one here. But it didn't put minus 3. So this. So the correct answer here is option B. Next up, question 3 says, which of the following metals will show the highest metallic character? A, zinc, B, copper, C, barium, D, calcium. So what is the correct answer to this? Now you want to note that metallic character increases down a group and decreases across a period. Note that barium, that's Ba, that's your symbol. So note that barium here is the lowest and the largest atom among the choices given here. Of course, barium here is in group 2 and period 6. So barium becomes the most metallic of them all. So the correct answer here is C, barium. But you want to take note that metallic character generally increases down a group and decreases across a period. So barium is the correct answer. Next up, question 4. Question 4 says, due to the unstable nature of ethine, it is stored by dissolving in A, ethane 1,2-diol, B, propanol, C, ethanoic acid, D, propane. So what's the correct answer here? Now note that we talked about the storage of ethine. So for this question here, you want to note that ethine is usually stored dissolved in a suitable solvent to stabilize it. And among the listed options here, the polar high boiling ethane 1,2-diol, that's option A here, is generally what is being used. So for this question, the correct answer here is A, ethane 1,2-diol. Next up, question 5. Question 5 says, in a chemical reaction, when the energy of the colliding reactant particle is less than the activation energy, the reaction will A, be spontaneous, B, not occur, C, occur, D, be slow. Now, to answer this question here, you want to recall that when we talk about this, the activation energy is the energy that is required before a reaction can occur. All right. It is the minimum energy that has to be surpassed before a chemical reaction can take place. So, if you look at this question, what they said, when the energy of the colliding particle reactants is less than the activation energy, you want to recall that the activation energy is the minimum energy that must be possessed by the particle before a reaction can take place. Hence, if this energy is less than the minimum energy, which is the activation energy, it means that the reaction will not occur. So the correct answer here is what? B. Because for any reaction to occur, then the activation energy barrier must be reached. And in a case where the energy of the colliding particle, reactant particle, is still lesser than the activation energy, that means nothing will happen or the reaction will not occur. That's your answer. Number 6. 6 says a gas that forms a black precipitate with lead-2 ethanoate is A. Chlorine, B. Ammonia, C. Hydrogen, D. Hydrogen sulfide. For this question, you want to note that lead-2 ions react with sulfur ions to give lead sulfide. That's this. All right. Now, this lead sulfide is a black precipitate. Now, also note that hydrogen sulfide, that's H2S, supplies the sulfur ion, that's S2 minus, that is required for this to be formed. So, in essence, the correct answer there would be hydrogen sulfide, H2S. All right. Take note of this. Question 7 says, which of the following pollutants is associated with brain damage? A. Carbon 2 oxide. B. Radioactive fallout. C. Biodegradable waste. D. Sulfur 4 oxide. Now, for this question here, the correct answer there is carbon 2 oxide. That's A. Note that carbon monoxide, right? This is also called carbon 2 oxide or carbon monoxide. Carbon 2 oxide binds to the hemoglobin and causes something called hypoxia. Write that down. Causes hypoxia, that's this, and can cause brain damage. So the correct answer there is carbon 2 oxide or carbon monoxide. That's your correct answer. All right. Question number 8. One of the methods used for combating air pollution is A. Burning of solid waste. B. Provision of sanitary landfills. C. Legislation against some industrial practice. D. Scavenging of refuse dumps. Now, the question here is a method used to combat air pollution. If you look at A says burning of solid waste. If you burn solid waste, of course, carbon waste will be created and this would cause air pollution. If you look at the next one there, provision of sanitary landfills. This does not in any direct way help to combat air pollution. Look at the D part. D part says scavenging of refuse dumps. If you scavenge refuse dumps, what happens is that you help to spread out the dumps, causing air pollution. So the correct answer here for question 8 would be C. All right. Laws should be passed against practices that causes air pollution. So the correct answer here is C, which is legislation against some industrial practice that could cause air pollution. That's it. Next up, question number 9. Question 9 says 5 moles of sulfur oxide plus 2 moles of potassium tetraoxomanganate plus 2 moles of water would give you potassium tetraoxosulfate plus 2 moles of manganese tetraoxosulfate plus 2 moles of hydrogen tetraoxosulfate 6. Of course, this is a reversible reaction. In the reaction above, the products give A. Purple solution, B. Purple precipitate, C. Colorless precipitate, D. Colorless solution. So what's the correct answer to this question? You want to note that the correct answer to this question there is D. Colorless solution. All right. Now for this question, you want to note that this one here, that's potassium tetraoxomanganate, is purple. And after reduction, the manganese in manganese tetraoxosulfate gives a colorless aqueous solution, and the sulfate salts are colorless. So this would give you a colorless solution. That's the correct answer. All right, next up, question 10. Question 10 says phosphorus pentachloride breaking down to give you phosphorus trichloride plus chlorine gas, and they give you the change in the heat energy to be what there? Positive. They said in the reaction above, the forward reaction is favored by A, increasing the size of the containing vessel, B, increasing the pressure, C, adding a catalyst, D, increasing the temperature. Now, for this question, you want to note that this reaction here is endothermic, and it is endothermic because the change in this, that's the heat energy there, is greater than zero. And it's greater than zero because it's a positive. You can see here, it's positive. So it is greater than zero. Hence, increasing the temperature will shift the equilibrium to the product, hence forwarding the forward reaction. So the correct answer to this question would be D, increasing the temperature. All right. Question 11 says, during a titration experiment, 0.05 moles of carbon 4 oxide is liberated. What is the volume of gas liberated? Take the molar volume of gas at STP to be equal to 22.4 dm cube. A, 22.40 dm cube. B, 11.20 dm cube. C, 2.24 dm cube. D, 1.12 dm cube. So how do we solve this question here? For question 11, for question number 11, this, you want to note that volume, right? Volume is equal to N, number of moles, times the molar volume of gas, times molar volume, volume of a gas at STP. All right. So this is equal to N represents the number of moles. If I come to the question here, you can see that they give us 0.05. That's the number of moles. So N is 0.05 multiplied by molar volume of a gas at STP, 22.4. So times 22.4. Multiply this 0.05 times 22.4. The answer here is 1.12. The volume is in dm cube. So I have my answer as 1.12 dm cube. The correct answer here is option D. All right, question 12. 12 says the impurities formed during the laboratory preparation of chlorine gas are removed by A, water, B, ammonia, C, hydrogen tetraoxosulfate 6, D, hydrochloric acid. Now, what to note here is that when preparing chlorine in the lab, example, if you use manganese oxide, that's this, plus combine this with hydrochloric acid, in the preparation of chlorine, you will get moisture or water vapor as an impurity. Now, concentrated hydrogen tetraoxosulfate 6 acid is used as a drying agent to remove the moisture. So what we use there is H2SO4, all right? It is used as a dehydrating agent or a drying agent in order to remove the moisture or the water vapor that is considered an impurity. That's the correct answer to this question. Next up, question 13. 13 says the minimum amount of energy required for a reaction to take place is, we've answered this in our previous video. The option A says activation energy, B says kinetic energy, C says lattice energy, D says ionization energy. The correct answer to this question there is A, activation energy. All right. The activation energy is the minimum amount of energy required for a reaction to take place. That's your correct answer. All right, question 14. The decolorization of the purple color of tetraoxomanganate 6 ion is a test for A, alkanals, B, alkanes, C, alkenes, D, alkanols. The correct answer here is C, alkenes. All right. Note that tetraoxomanganate 6 ion, which is KMNO4. This is also called permanganate, is decolorized by unsaturated double bonds because it oxidizes alkenes readily. And this is also used as a test for the permanganate, also called tetraoxomanganate 6 ion. And what happens is that when you use this, when you combine this with alkenes will decolorize it. So the answer there is alkenes. All right. Next up, question 15. Which of the following halogens is the most reactive? A, chlorine, B, iodine, C, bromine, D, fluorine. For this question there, the correct answer there is D, fluorine. So you want to note that for the halogens, that reactivity decreases down the group. So for the listed elements here, in order of decreasing reactivity, we'll have that fluorine is the most reactive, greater than or followed by chlorine. After chlorine, the next one you have there is bromine, and after bromine you have iodine. So of all listed here, the most reactive is fluorine, while the least reactive is iodine. All right. So take note of this. Next up, question 16. 16 says, which of the following is a hygroscopic substance? A, sodium trioxonitrate, B, magnesium chloride, C, iron 3 chloride, D, calcium chloride. Now, the first thing we want to note here is the meaning of hygroscopic substance. A hygroscopic substance is simply a substance in which, when exposed to air, it forms moisture. Now, for this question, you want to note that many chlorides are hygroscopic or deliquescent. Calcium chloride is widely used as a drying agent, all right, because it absorbs moisture strongly. So you say which of the following is a hygroscopic? Say technically, B, C, D, having chlorine, are all hygroscopic substances, but the most hygroscopic of them all is calcium chloride, that's CaCl2. That's your answer. I think for this question, it should rather be which of the following is not a hygroscopic, all right? I think there should be a not. And if there's a not here, then the answer would be this NaNO3. Because as I said earlier, chlorine compounds, all right? That's many chloride, that's MgCl2, FeCl, and then CaCl2. They are all hygroscopic substances. So you want to take note of this. But for this, we'll pick up D because this is literally one of the most hygroscopic substance. So the answer there is calcium chloride. 17 says ethine is passed through a hot tube containing organonickel catalyst to produce A, isoprene, B, polythene, C, ethanol, D, benzene. So what is the correct answer to this question? For question number 17, the correct answer there is D, benzene. All right. So for this question, you want to note that under suitable conditions, ethine trimerizes to form benzene. And by that, I mean 3 moles of ethine, C2H2, all right, under heat would form benzene, that's C6H6. This is what is called trimerizes, all right, means 3 moles of it to give you benzene. So that's it. Right, so the correct answer is D, benzene. Question number 18. The difference between colloids and suspension is brought out clearly by the fact that while colloids A do not scatter light, suspensions do. B can be separated by filtration, suspension cannot be separated. C can be separated by membrane, suspensions cannot. D do not settle out on standing, suspensions do. What is the correct answer to this question? Now, for this question, you want to note that colloids remain dispersed and do not settle on standing, whereas suspension do settle out on standing. So the correct option here is D. All right. Colloids do not settle out on standing, meanwhile suspensions do. So that's your correct answer. Question number 19. What is the percentage of sulfur in sulfur oxide? All right. How do we solve that? We want to find, that's 19. We want to find the percentage of sulfur in SO2, sulfur oxide. Now, how do you find this? The first thing you want to do is to get the molar mass of sulfur oxide. For sulfur, the molar mass there, for sulfur, the atomic mass is 32. This plus, for oxygen, the atomic mass is 16. So it becomes 16 times the number of atoms. You have 2 atoms of oxygen, so times 2. If I work on this, this becomes 32 plus 16 times 2 gives you 32. That becomes plus 32. And that becomes 64 gram per mole. So you have 64 gram per mole. Now from this, to get the percentage composition of sulfur, is simply, so have percentage composition, position of sulfur is simply equal to the mass of sulfur, mass of sulfur, spell this correctly, mass of sulfur all over molar mass of SO2 times, that's SO2, yep, times 100%. So this is equal to the mass of sulfur, or the atomic mass of sulfur as we know it, is 32. That becomes 32 all over the molar mass of the compound of SO2. Molar mass is 64 all over 64 times 100%. If you work on this, this will give you 0.5. So 0.5 times 100%. That is 32 over 64 gives you 0.5. 0.5 times 100 gives you 50. So that means the percentage composition of sulfur in sulfur oxide is 50%. All right, so let's see what we have here. So the answer there, correct answer is D, 50%. Question 20. The number of hydroxonium ions produced by one molecule of an acid in aqueous solution is its A. Basicity, B. Acid strength, C. pH, D. Concentration. Now for this question, you want to note that there is something called basicity, all right? And by definition, basicity is simply the amount of replaceable hydrogen ion or hydroxonium ion present in a compound which is acidic. So in this question, in this particular question here, the correct answer there is basicity. Question 21 says a few drops of concentrated hydrogen trioxynitrate is added to an unknown solution and boiled for a while. If this process produces a brown solution, the cation present is likely to be A. Lead 2 ion, B. Copper 2 ion, C. Iron 3 ion, D. Iron 2 ion. So for this question, it says if this produces a brown solution, the cation present is, the correct answer there is C. Iron 3 ion. All right. So this nitric acid, HNO3, would oxidize iron 2 ion to produce iron 3 ion, which of course produces a brown solution. So the brown solution indicates the presence of iron 3 ion. That's the correct answer. Question 22. The process of converting starch to ethanol is A. Cracking, B. Distillation, C. Fermentation, D. Oxidation. For this question here, you want to note that The correct answer is C, fermentation, right? So fermentation is the process that we use in the conversion of starch to ethanol. Question 23. The effect of the presence of impurities such as carbon and sulfur on iron is that they A. Give it high tensile strength, B. Make it malleable and ductile, C. Increases its melting point, D. Lowers its melting point. Now, for question 23, you want to note that carbon in iron or steel increases hardness and tensile strength, but lowers its ductility. Sulfur makes iron brittle. So for this question here, the net effect is that it will increase the tensile strength. So for this question here, the correct answer is A. It gives it a high tensile strength. Next up, question 24. 24 says an element X has electron configuration 1x squared, 2s squared, 2p to the power 6, 3s squared, 5p to the power 5. Which of the following statements is correct about the element? A. It has a completely filled p orbital. B. It has 5 electrons in its outermost shell. C. It belongs to group 2 on the periodic table. D. It is a halogen. Now, for these elements that they call X, let's look at the atomic number. Now, to get the atomic number, all we have to do is to count the numbers here. So this becomes 2 plus 2, that's 4. 4 plus 6, that gives us 10. 10 plus 2, that gives us 12. 12 plus 5, that gives us 17. So in total, you have X having atomic number 17, right? You have atomic number 17. And we know that if I do the KLMN shell configuration, that becomes 287. So you observe that element X has 7 electrons on its outermost shell. What does that mean? It means it is a halogen. All right. So the correct answer there is D. It is a halogen. Halogens are elements that have 7 electrons on their outermost shell. So that's it. 25. In the laboratory preparation of oxygen, dried oxygen is usually collected over A. Hydrochloric acid, B. Mercury, C. Calcium chloride, D. Tetraoxosulfate 6 acid. For 25 here, the correct answer is C. That is calcium chloride. Now, the reason is that to dry gases, common drying agents used is calcium chloride, that's CaCl2, right? So the common drying agent that we use to dry gases is calcium chloride, or in some cases, would use hydrogen tetraoxosulfate 6, or we could still use phosphorus pentoxide, right? So any of these can be used. Now, given the options there, the correct answer there is calcium chloride. That's CaCl2. That is option C. And one extra thing is that fused calcium chloride does not react with oxygen under normal condition. So since this will not react with the oxygen, it becomes a perfect fit that should be used to dry oxygen. Okay, next up, question 26. 26 says the general formula of haloalkanes, where X represents the halide, is you have option A, B, C, and D. Now, how do we answer this question here? First things first, they mentioned alkanes before the halo. So for alkanes, recall that the general form of an alkane is CnH2n plus 2. This is the general form of an alkane. Now, when you have a haloalkane, that simply means an alkane that has one molecule. And for this alkane to receive one molecule, it has to lose one of the hydrogen atoms. Now you have a plus 2 of hydrogen. So I will lose one of the hydrogen, it becomes plus 1. Then I'll attach the halogen, so it becomes X. So it becomes CnH2n plus 1X. So let's see which option that is. That is option D, CnH2n plus 1, then X. That's your correct answer. Next up, question number 27. 27 says the monomer of natural rubber is A. 2-methyl-but-1,3-diene, B. 1-butene-3-ine, C. buta-1,3-diene, D. 2-chloro-buta-1,3-diene. For 27, The correct answer there is A, 2-methyl both 1,3-diene. So you want to also take note that 2-methyl both 1,3-diene is also called isoprene. All right, this is also called isoprene. And this isoprene here is the monomer of natural rubber. All right, so take note of this. Next up, question 28. Question 28 says 2 moles of sodium peroxide combines with 2 moles of water to give you 4 moles of sodium hydroxide plus 1 mole of oxygen gas. The substance that is oxidized in the reaction is, so you have your option A, 2 moles of sodium peroxide, B, sodium hydroxide, C, water, D, hydrogen gas. So which of these is being oxidized in this particular reaction? Now, if you consider the reactant for sodium peroxide, that's this, you want to observe that the oxidation number of oxygen here is -1. That's in sodium peroxide. Meanwhile, if you come to the products part where we have a molecule of oxygen gas, the oxidation number of oxygen here is 0. Now, looking at this, the concept here is that water is being used as an oxidizing agent to oxidize oxygen here. And when we say to oxidize, we mean to add an oxygen atom to something. That's what it means to oxidize, okay? You are adding an oxygen atom. And that's why when you had -1, we added an oxygen atom, so plus 1 atom of oxygen, that became 0. And that's why you have a 0 oxidation number of oxygen here. In essence, H2O is the oxidizing agent. But in this question here, we will not ask for the oxidizing agent. We are asked the substance that is being oxidized. And the answer would be sodium peroxide, because you're adding water to sodium peroxide. So sodium peroxide becomes the substance or the compound that is being oxidized. So the answer here is A. The 2 moles of sodium peroxide is the correct answer. Okay, question 29. 29 says the common ore of iron is A, bauxite, B, galena, C, cassiterite, D, magnetite. Now for 29 here, the simple answer there is D, magnetite, right? Magnetite is the simple ore of iron, right? The chemical formula for this is Fe3 and then O4, right? So magnetite is an important iron ore. So that's the correct answer. Now, finally, question 30. 30 says, which of the following will produce a solution with pH less than 7 at equivalent points? You have option A, B, C, and D. Now, for this question, you want to note something. Now, for you to have a pH less than 7, you must be having a combination of a strong acid. So it should be a strong acid combining with a weak base. All right. When you combine a strong acid and a weak base, the pH would be less than 7. So if you look at this here, for your acids here, I think almost all the acids here are strong acids. Let's look at which of them here is a weak base. Now for this question there, the weak base you have is magnesium hydroxide, MgOH. So for this question here, having a strong acid as hydrochloric acid and a weak base as magnesium hydroxide would give you a solution whose pH is less than 7 at equivalent points. So the correct answer here is C. Question 31 says, the oxidation number of boron in sodium tetrahydridoborate, that's NaHB4, is A -3, B -1, C +1, D +3. Let's write out this compound here. What I have here is NaBH4. We are asked to find the oxidation number of boron here. Now, for sodium, we know that for sodium, the oxidation number of sodium is +1, plus for boron, we do not know, we'll call it X, plus for hydrogen, the oxidation number is always -1, multiplied by 4, the number of atoms. So this, of course, will equate it to 0. so equal to 0. Because it's a neutral atom, this becomes 1 plus x plus minus 1 times 4 is minus 4 equal to 0. I have 1 plus x plus minus 4 is minus 4 equal to 0. So this becomes 1 minus 4 is minus 3. Minus 3 plus x equal to 0. To get the value of x here, x will be equal to minus 3 comes over here becomes plus 3. Hence, the oxidation number of boron in that compound is plus 3. So for this question there, the correct answer is D, plus 3. Next up, question 32. It says the polymer used in making car rear light is A. Perspex, B. Bakelite, C. Polystyrene, D. Polyacrylonitrile. Now for this question here, you want to take note that the correct answer there is A. Perspex. All right. So this is the polymer used in making car rear light. All right. And the reason is because it is clear, it is hard, and it is also weather resistant. Next up, question 33. It says if the heat of combustion of hydrogen is minus 285.8 kilojoules, what is the heat of reformation of water? A plus 571.6 kilojoules, B minus 571.6 kilojoules, C minus 285.8 kilojoules, D plus 285.8 kilojoules. Now for this question here, they said the combustion of hydrogen. All right. Now for this question here, the equation for the combustion of hydrogen is given by 2H2 plus O2, and this would give 2 moles of water, H2O. So you want to see that from this particular reaction here, we are given the heat value as minus 285.8 kilojoules. And when this reacts, it forms water. Now, if you're looking at the reformation of water, this reformation of water is the direct opposite of what we already have here. That means water coming back to this. And it is the reverse, also known as the reformation or decomposition, which will have the same value of heat but opposite side. Okay. So when you have the combustion of hydrogen to give you water here, the opposite happens when it comes to the reformation of water. So you have the exact same heat value but opposite sign. So the answer becomes the same value, 285.8, but opposite sign, so it becomes plus. So for this question there, the correct answer there is D. 34. If the difference in electronegativity of elements P and Q is 3.0, the bond that will be formed between them is A. Metallic, B. Covalent, C. Coordinate, D. Ionic. Now for this question here, the correct answer there is D. Ionic. Now it's ionic because large electronegativity difference, that is electronegativity difference, that is electronegativity difference that is greater than 1.7, all right, forms ionic bonds. Also, for electronegativity difference to be high, it means that the element involved is a very electropositive element and a very electronegative element, that is a metal and a non-metal. And we know that when a metal and a non-metal combines, they form ionic bond. So ionic bond is the correct answer. 35. The reaction of sucrose with dilute hydrochloric acid produces A. An alkaline, B. Glucose and fructose, C. A black mass of carbon, D. Polysaccharide. Now for this question, you want to note that acid, that's HCl, plus sucrose would lead to the formation of glucose and fructose. All right. So it gives you glucose and fructose. So the correct answer there is B, glucose and fructose. Next up, question 36. How will a metal X, which reacts explosively with air and with dilute acid, be best extracted from its ore? A. Electrolysis of the solution of its salts. B. Decomposition of its oxide. C. Displacement from solution by an alkali metal. D. Electrolysis of fused salt. Now, for this question, the correct answer is D, the electrolysis of fused salt. And the reason is because very reactive metals, which either explode in air or react with acids, are extracted by electrolyzing the fused salt. Example, salt like sodium, salt like potassium, salt like calcium. So the correct answer here is electrolysis of fused salt. And also, since the metal is reactive, using electrolysis would be the best as the electrode could be inert. Example, platinum. So for this question here, the correct answer would be D, the electrolysis of fused salt. Question number 37. The bleaching action of chlorine gas is effective due to the presence of A. Hydrogen chloride, B. Water, C. Air, D. Oxygen. For this question, you want to note that the combination of chlorine and water, so chlorine plus water, will result in the formation of hypochlorous acid, that's HOCl, right? HOCl. And this hypochlorous acid is a bleaching agent. Okay, so that means water must be present. So the correct answer there is B, water. You also want to take note that the bleaching action of chlorine is only possible when chlorine is in this particular form here. By this form, I mean the hypochlorous acid form. And this hypochlorous acid form only appears or is only possible when chlorine reacts with water. All right. So it is due to the presence of water. That is the correct answer. Water. Next up, question 38. A major factor considered in selecting a suitable method for preparing a simple salt is its A. Crystalline form, B. Melting point, C. Reactivity with dilute acids, D. Solubility in water. For this question here, the answer is D. Solubility in water. For this question here, the correct answer is D. Solubility in water. You want to take note that the solubility of simple salt in water is a major factor considered. And this is because to get salt out finally through precipitation, the salt must not be soluble in water. All right, so the answer becomes D, solubility in water. Next up, question 39. 39 says 200 cm cube of a gas at 25 degrees Celsius exerts a pressure of 700 millimeter mercury. Calculate its pressure if its volume increases to 350 cm, that should be cm cube, right? Cm cube at 75 degrees Celsius. A, 342.53 millimeter mercury. B, 1430.54 millimeter mercury. C, 467.11 millimeter mercury. D, 400.00 millimeter mercury. So for this question, observe we are given volume in cm cube, we are given temperature in degrees Celsius, we are given pressure in millimeter mercury. Hence, we're going to be using the combination of Boyce and Charles law. That is P1 V1 all over T1 is equal to P2 V2 all over T2. Now let's impute values. The value of P1 is your first pressure, which is given as 700 millimeter mercury. So I'm having 700. P1 is 700 into V1. The value of V1 is 200 cm cube. That's V1, 200 in cm cube all over. They give us temperature T1 here at 25 degrees Celsius. Of course, convert to Kelvin, becomes 25 plus 273. And if we do this, this gives us 298 Kelvin. All right. So converting to Kelvin, I have 298 Kelvin. So the T1 becomes 298. 298 is equal to, for P2, your second pressure is what you're asked to find. They calculate its pressure. So we don't know the value of P2. Let's call this P2. What about V2? Let's see the second volume there. Second volume there is 350 cm cube. So I have 350. That's V2 all over. Let's see T2. T2 is 75 degrees Celsius. Convert to Kelvin. It becomes 75 plus 273. If you add this up, that becomes 348 Kelvin. All right, so summing this, I have 348. So T2 is 348. So let's solve this. This becomes cross multiply this and this. We have P2 times 350 times 298 is equal to, cross multiply this, it becomes 700 times 200 times 348. We have this. All right, to get this, I'll simply divide this by 350 times 298. Divide this by 350 times 298. So this will cancel this will cancel this. So P2 it's equal to, I'll get my calculator and punch all of this correctly. So for numerator, I have 700 times 200 times 348. Now divide this by the product. So divided by, open a bracket, type 350 times 298, close the bracket. This gives you 467.11 approximately. And this was given in millimeter mercury, so mmgh. So do we have a 467.11 millimeter mercury? Yep, that's option C. So option C, 467.11 millimeter mercury is the correct answer. All right, finally, question 40. Question 40 says a gas X diffuses twice as fast as gas Y. Question 40 says a gas X diffuses twice as fast as gas Y. If the relative molecular mass of X is 32, calculate the relative molecular mass of Y. A 128, B 8, C 16, D 64. So how do we solve this question? To solve question 40, I'll need an idea of Graham's law of diffusion. Graham's law of diffusion. Now, from Graham's law of diffusion, you have that the rate of diffusion of a gas is inversely proportional to the square root of its molar mass. Now, for gas X, you have that the rate of diffusion of gas X is inversely proportional to the square root of the molar mass of gas X. So you have this. Also, for gas Y, the rate of diffusion of gas Y again is inversely proportional to the molar mass of gas Y. So I'll call this my first equation, equation 1, and call this my second equation, equation 2. If I divide equation 1 by equation 2, I'll have Rx divided by Ry is equal to what I have for X here. That's 1 all over the square root of the molar mass of X. This divided by 1 all over the square root of the molar mass of Y. We have this. Okay, so X for this and then Y for this. Now let's work on this fraction. What I have here is simply 1 all over the square root of the molar mass of X divided by 1 all over the square root of the molar mass of Y. And to solve this, of course, I'll change division to multiplication. That becomes 1 all over the square root of the molar mass of X multiplied by, I'll invert this one here. That means denominator goes up, numerator comes down. Becomes the square root of the molar mass of Y all over 1. And if they multiply, this will be equal to 1 times the square root of the molar mass of Y gives you the square root of the molar mass of Y all over square root of molar mass of X times 1 gives you the square root of the molar mass of X. So this expression here, this is equal to, don't forget this was equal to Rx, that's rate of diffusion of X to rate of diffusion of Y. So this is equal to Rx all over Ry. I only simplify this part. That is this part here. All right, I simplified this part here and I had this answer. Again, looking at the question there, if you come back to the question there, for question 40, looking at the side, a gas X diffuses twice as fast as Y. That means the rate of diffusion of X is equal to twice, that's 2 times that of Y. So we are saying that Rx, Rx is equal to 2 Ry basically. Let's impute values. If I substitute Let's substitute values. In place of Rx, I'll put 2Ry. So this one here becomes 2Ry all over what I have here. That's Ry. It's equal to the square root of the molar mass of Y all over the square root of the molar mass of X. Let's get the values and impute them here. So let's get the values for this. The rate of diffusion of Y, let's get the value. Let's see. For this question here, they said if the relative molecular mass of X is this, so for X is 32, then it said calculate the relative molecular mass of Y. All right, let's also find the relative molecular mass of Y. So for X is 32, for Y it's unknown. Let's get that value. So I'll come here. At this point here, they said the molecular mass of X is equal to 32. Now, looking at this equation here, you see that Ry will cancel Ry. So you're left with 2 all over 1 is equal to the square root of the relative molecular mass of Y all over the square root of, for the relative molecular mass of X, we got the value as 32. All right, so let's solve this. Now in solving this, of course, cross multiply. This times 1 is itself. So you have square root of the molecular mass of Y. It's equal to 2 times root 32. That becomes 2 root 32. We have this. So for this, now to solve this, of course, I have to square both sides. So it becomes root molecular mass of Y all squared is equal to use 2 root 32 all squared. So from here, you have that this will cancel this. Molecular mass of Y, it's equal to, now to work on this, 2 squared, that gives you 4 into this same square will cancel square root. That becomes 4 times 32. All right, so that's how you solve this. So if you have 2 root 32 all squared, it's equal to 2 root 32 multiply itself, 2 root 32. So 2 times 2 gives you 4. Root 32 times root 32 gives you 32. So we have this. So from this, we can see that the molecular mass of Y is equal to 4 times 32 gives you 128. All right. So for this question here, the correct answer there is 128. So let's see which option has 128 there. So going through this, the answer there is A, 128. That's a correct answer. Question 41 says beryllium and aluminium have similar properties because they A, are both metals, B, belongs to the same group, C, belongs to the same period, D, are positioned diagonally to each other. So what's the correct answer to this question? The first thing you want to note is that beryllium with atomic symbol Be is under group 2 and period 2 in the periodic table. Also, aluminium with symbol Al is in group 3 and period 3 of the periodic table. And hence, in your periodic table, if you check under group 2 and group 3, you have beryllium here, right? Group 2 and the second row. Also, you have aluminium here, which is group 3 and period 3, that's third row. Looking at this, you observe that they form something called a diagonal relationship, right? They formed a diagonal relationship. Now you want to note that there is something about elements that form diagonal relationship, and that is that elements that show or form diagonal relationships usually have similar properties due to them having either similar charge or similar radius or similar polarization path. So for this question here, they said beryllium and aluminium have similar properties because the correct answer would be D. That's D, because they are positioned diagonally to each other. All right. Don't forget that when elements have diagonal relationship, they usually have similar properties due to similar charge or similar radius or similar polarization path. So the correct option there is D. Question 42. You have this. This is ethyl ethanoate plus water produces ethanoic acid plus ethanol. The question here says the purpose of hydrogen ion in the reaction above, that's this one here, is to A, increase the yield of products, B, maintain the solution at a constant pH, C, increase the rate of hydrolysis, or D, decrease the rate of the reverse reaction. Now for this question, you want to note that H plus, which is hydrogen ion, for this particular reaction acts as a catalyst, more specifically an acid catalyst, and it aids for ester hydrolysis. What you have here, ethyl ethanoate, is an ester, and this reaction here is the hydrolysis of an ester. For this particular hydrolysis of an ester, you need hydrogen ion to make the reaction occur faster, which means hydrogen ion acts as a catalyst to increase the rate of the hydrolysis. And don't forget that catalyst increases the rate of a reaction by lowering the energy barrier or the activation energy. So considering the options here, the correct answer is C, to increase the rate of the hydrolysis of the ester here. So that's the correct answer, C. Question 43, you have 3 moles of iron plus 4 moles of water to produce iron 2,3 oxide plus 4 moles of hydrogen. The question says the equilibrium constant K of the reaction above, that's this, is represented as, you have option A, option B, option C, and option D. So what's the correct answer for this question? Now for this question, you want to recall that equilibrium constant K is equal to the concentration of products, right? Just a reminder, concentration of products raised to power n, where n here is simply the number of moles of each product divided by the concentration of reactants. So this of reactants to power m, where m is the number of moles of the reactants. Now with this, let's try to answer this question. For this question, the K equilibrium constant will be equal to, let's start with products. For the product part, we have this and this one here. Let's take the first one, which is this. Here you have, open a square bracket, Fe3O4. You have this. This will be raised to power. The coefficient here is 1, right? So it will be raised to power 1, which is the same thing as just this. It's the same thing. The next product here is hydrogen, H2. So H2 raised to the number of moles. or the number attached to it, which is 4, raised to the number attached to it, which is 4. So this all divided by, so we're done with products. Let's take reactants. For reactants, the first reactant I have there is Fe, that's iron, having 3 moles. So square brackets, Fe, iron, having 3 moles. And then finally, you now have H2O, water, having 4 moles. So H2O, water, having 4 moles. So this is the correct answer. So let's look at this. Which of this option has this answer? Okay, I think what is similar there is D, but D does not have the last one. So come to D. Perhaps it's a typo error. We'll now add H2O to power 4. Now it's correct. So this 3 is not up, this 3 is down. This 4 is not up, it's down. The H2 is not up, it's down. All right, so with this, we now have Fe3O4 into H2 to power 4 divided by Fe to power 3, then H2O to power 4. So we'll take D as the correct answer. All right. So basically, this is how this is done. Okay. Concentration, which is represented by square brackets of products, all raised to the power of for each of them, their number of moles, all over concentration of each reactant raised to the number of moles. So option D is your answer. Question 44. In an endothermic reaction, if there is a loss in entropy, the reaction will A, not be spontaneous, B, be at equilibrium, C, be indeterminate, D, be spontaneous. So what is the correct answer to this question? Now, for this question 44, you want to note that if there's a loss in entropy, the average kinetic energy is also reduced. Okay? When there's a loss in entropy, the average kinetic energy will also be reduced. And when the average kinetic energy is reduced, the temperature will also reduce. Hence, the temperature decreases. Now, since the reaction is endothermic, as stated, it will only be spontaneous when there is an increase in temperature. So for an endothermic reaction, it will only be spontaneous if there's an increase in temperature. But then, considering that we have a loss in entropy, there will be a reduction in temperature. So what will happen? You now observe that this particular reaction will not be spontaneous. Why? Because the temperature that we need, or the increase in temperature that we need for it to be spontaneous, is not given. Instead, we have an opposite case where there is a loss in entropy and hence a loss in the kinetic energy and hence a loss in temperature, which will now result in the reaction not being spontaneous. The correct answer is A. It will not be spontaneous. Please take notes. Next up, question number 45. 45 says the radioactive radiation used in studying the arrangement of particles in giant organic molecules is A. Gamma rays, B. Alpha rays, C. X rays, D. Beta rays. Now for 45, you want to take note that the correct answer here, or the correct option here, is C. X rays. All right. Note that X-rays, they are used to study arrangement or structures of large molecules or crystals. And why is this so? This is so because X-rays have more penetrating power. So the correct option there is C, X-rays. Next up, question 46. The alkanol obtained from the production of soap is A. Propanol, B. Ethanol, C. Glycerol, D. Methanol. Now, for this question here, the correct option is C. Glycerol. First things first, you want to note that the process that is used in the production of soap is called saponification. So you have saponification. Now, this saponification process produces two things there. The first thing you have is soap. The first thing you have there is soap, and then after soap, you now have glycerol. All right, you have glycerol. So it produces soap as well as glycerol. So hence, the alkanol obtained is actually glycerol. And you want to take note that the proper IUPAC name for glycerol is actually propan 1,2,3 triol. All right, so it produces propan 1,2,3 triol. And this is a trihydric alcohol. This is the same thing as glycerol. So the correct answer there is glycerol. Question 47. 47 says in the electrolysis of, this should be CuSO4. Yep, that's it. Okay. 47. In the electrolysis of copper tetraoxosulfate 6 using platinum electrodes, the reaction at the anode is, you have option A, option B, option C, and option D. So how do we answer this question here? Now, take note that at the anode for 47, at the anode, the reaction there is 4 moles of hydroxide ion would give you 2 moles of water plus oxygen plus 4 electrons. So 4 electrons there. All right. Now, this is the standard anodic process for aqueous electrolysis with platinum. Now, this is known as the standard anodic process for aqueous electrolysis with platinum. If I move the number of electrons to the left-hand part of the equation, I'll be having 4 moles of the hydroxide ion. Move this over here. This was positive, it becomes negative, so it becomes minus 4 electrons, and that will yield 2 moles of water plus oxygen. So you have this. So let's check which option has this particular answer. So let's see this for question 47. Now, inspecting this, we can see that the correct option there is B. Look at this. That's what we got. All right. So B is your answer. 4 moles of hydroxide ion minus 4 electrons will produce 2 moles of water plus oxygen. Next up, question number 48. 48 says a few drops of sodium hydroxide solution was added to an unknown salt, forming a white precipitate which is insoluble in excess solution. The cation likely present is A, zinc 2 ion, B, lead 2 ion, C, calcium ion, D, aluminium ion. Of course, aluminium ion is supposed to be Al3 plus, so correct the 3 plus. All right, so we have this. All right, so which of this is the correct answer? First things first, you want to note that if this zinc 2 ion combines with sodium hydroxide, what you have there is zinc hydroxide, that's ZnOH2. You have this. And zinc hydroxide is white, but it dissolves in excess sodium hydroxide. The question said, which is insoluble, that it does not dissolve in excess of the solution of sodium hydroxide. This one dissolves, so A cannot be the answer. Look at C, calcium ion. If calcium ion combines with sodium hydroxide, you have this. So you have this. That's calcium hydroxide. Now, this is calcium hydroxide is slightly soluble, all right? It's slightly soluble. So it is not insoluble. It's actually slightly soluble. So C cannot be the answer. If you look at aluminium hydroxide, if you look at aluminium ion, when this combines with sodium hydroxide, you'll be having aluminium hydroxide, which is Al. Let me write this better. AlOH3. So this will be formed. Now you want to note that for this one here, aluminium hydroxide is white. So yes, a white precipitate. This is supposed to be white. Okay. A white precipitate will be formed, but then this precipitate also dissolves in excess sodium hydroxide. So let's find which of these does not dissolve. The correct answer there will be B, because when we have lead 2 combining with sodium hydroxide, what you have there is lead hydroxide. This is white, all right? It forms a white precipitate, and this white precipitate does not dissolve in excess sodium hydroxide solution. So hence we can say it is insoluble in excess sodium hydroxide solution. So the correct answer there is B. All right. So take note that B, that's lead 2 ion, is the correct answer. All right. Okay. Next up, let's look at question number 49. 49 says 2 moles of sulfur 2 oxide plus oxygen would yield 2 moles of sulfur 2 oxide. The change in heat energy is equal to minus 395.7 kilojoules per mole. The question here says, in the reaction above, that's this, the concentration of sulfur 2 oxide can be increased by A, increasing the temperature, B, the addition of a catalyst, C, decreasing the pressure, D, decreasing the temperature. So which of these is the correct answer? Now, the first thing you want to note for this reaction is that this particular reaction is exothermic. All right, it's an exothermic reaction. Now, how do I know that this reaction is exothermic? It's simple, because the change in heat energy is negative. So whenever your change in heat energy is negative, you have an exothermic reaction. So decreasing the temperature of this particular reaction would shift the equilibrium towards the product or the product side according to Le Chatelier's principle. Also, for an exothermic reaction, the temperature of the product is lesser than that of the reactants. So for more product to be formed, the temperature of the system has to be reduced, which will allow the equilibrium position shift to the product side. So for this question here, the correct answer there is D. We have to decrease the temperature. All right. So you have to decrease the temperature. So decreasing the temperature here will allow the equilibrium position to shift to the product side. So that's the correct answer, D. Finally, question 50. How many protons, neutrons, and electrons respectively are present in the element? This CO is actually cobalt. You have option A, option B, option C, and option D. So cobalt there is atomic number 27. So cobalt, atomic number 27, mass number 60. You're asked respectively protons, neutrons, and electrons. The number of protons, P, neutrons, and electrons, E. All right, so how do we solve this question? What do we do? The first thing you want to notice is that the easiest to get is number of protons. And number of protons is equal to the atomic number, which is the number at the lower left part of this, which is 27. So number of protons is 27. Let's get the number of neutrons. For neutrons, you want to take note that the mass number, which is the one here, 60, mass number is equal to proton plus neutron. The number of protons plus number of neutrons gives you the mass number as 60. We already have the number of protons as 27. So you have 27 plus n is equal to 60, where n is number of neutrons. So n will be equal to 60 minus 27, and that's equal to 33. The number of neutrons is 33 neutrons. Finally, for electrons, that will be equal to, again, you want to note that for a neutral atom, number of protons is equal to number of electrons. How do I know that this particular atom is neutral? The atom does not have negative or positive. So whenever you have an atom that does not have either a negative sign or a positive sign attached to it, it is simply a neutral atom. And for a neutral atom, number of elements or number of electrons is equal to number of protons. And since we have number of protons at 27, this is equal to 27. So the number of protons, neutrons, and electrons becomes 27 protons, 33 neutrons, and 27 electrons. So it becomes 27, 33, 27 respectively. So let's see which option is that. That is option C. So option C becomes the correct answer. So if you enjoyed this video and you want more JAMB examination past question and solution for JAMB Physics, JAMB Chemistry, JAMB Mathematics, and JAMB Biology, simply hit the like button, subscribe to this channel, and turn on the bell icon. All right, hit the bell icon and select all so that you get notified whenever we publish our daily JAMB past questions and answer. Okay, guys, so please take note that we have a JAMB WhatsApp group for 2026 JAMB Bites. All right. So if you're writing JAMB for 2026, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bites, or you can get the full JAMB course on our website. Simply visit www.journalimmanu.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. Right, for the comments, I gave you a task, question number 11. Solve it, leave your answer in the comment section, and I will tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon, and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.